All right, so when we're using our ruler to help us solve problems, now let me see, for some reason, I've only got number 3 up there. So let's take a look at number 2A. All right, 2A was 3x. Actually, I did that one. So let's do 2A number B, which was 3x minus 2 equals 5, right? And our task is we're trying to figure out what x is from that function. And all we have to do is use the graph. So we're going to move our ruler to 5 on the y-axis because it already gave us the y. Is everybody with me on that? Do you understand how I'm getting y? It's when our function, y is always the function. So y equals 3x minus 2. And then if it tells us over here that 3x minus 2 equals 5, well then in that case, y equals 5. Are we on the same page with that, you guys? Like, be confident. Tell me for sure. Like, do we get that? We're good with that step. Okay, so then we don't need to do algebra. We don't need to solve this problem in our heads. We don't need to solve it with bar models. All we need to do is put our ruler on the 5. Right there. Use the ruler to find out where on the line, the graph of the function, where the line intersects y equals 5. And for some reason, my pen doesn't want to work, but it's like making a tiny little point. All right, which is right there. And then all I'm doing is I'm going to flip my ruler 90 degrees. Is this the same graph that we have on there?
Yeah.
I marked it on the wrong. Oh yeah, because it's 5. I was still thinking y was equaling 4. All right, then I'm just using my ruler and just using it to help me mentally draw a line down to the x-axis and see where it connects, right? What my x coordinate is when y equals 5. Okay, so what is my x coordinate when y equals 5? It's right here. And notice I've got these divided up into thirds here. So Rajveer, what is x right there? 2 1/3. Good. So I'm going to mark 2 1/3. And then how would I write my ordered pair for that particular coordinate? Uzziah?
5 and 2 1/3.
Good. Now you did get those numbers right, but which one needs to come first, x or y?
X.
Yeah, so we're going to need to write 2 1/3, comma, 5. That's my ordered pair. Shafiq.
What is the fraction?
It's not always the fraction. It only happens to be a fraction right now. X always goes first.
Oh.
So it always has to be x. Landon? Okay. Is there what? So those are 3 different y coordinates, the same function for all 3. Okay, so remember how we put the numbers into a table on Friday? And we said, like, let's say our function is y equals x plus 3. Okay, y is always going to equal whatever x plus 3 equals. That's just an easier one for us to visualize. Then, Landon, what would y equal when x equals 1? Like, don't look at your sheet. I'm just asking you to do mental math right now. So if our function is, let's say our function is y equals x plus 3. This is just easier to visualize. What's y if x is 1? No, y is x plus 3. That's our function that we're just trying to visualize right now. X equals 1, y equals. You see what I'm saying? Like if x equals 1, y would equal 1 plus 3. So y would equal 4. Does that make sense? Okay. What happens if x equals 2 with this function? What would y be? Yeah, which would be 5. What happens if x equals 3? And that would be, yes. So those coordinates would all fall in a line. They would look something like, let's see, y would be 1, x would be 4. I'm sorry, x would be 1, y would be 4, x is 2, y would be 5. It would look like this, x is 3, y is 6. They would make a line. And that line would be called a function. That's what that function would look like. We're just dealing with a more complicated function right now when we say that y equals 3x minus 2. Every time it tells us something different, like 3x minus 2 equals 4, right? We're trying to find x. X is going to be something different when y is 4. X is going to be different when y is 5, and x is going to be different when y is 6. Does that make sense? So like what we're trying to do with each one of those problems is we're just trying to solve for x. There's another way to solve for x. We could actually just do the math. We could do 3x minus 2 equals 4. Well, then that would mean that 3x equals 4 plus 2, which is 6. That would mean x equals 2. We could go through all of that. That's called balancing the equation, and we did that like last week. But this, with this method, what we're doing right now is we're just lining up x and y and using the ruler to like see where the line intersects and see what the other coordinate is. So it's easier once you get the hang of it. You're like, I don't believe you that it's easier, but it is. All right, so this was number 2. This is number 3. Sorry, my PowerPoint's wanting to be squirrely here. This is number 3. Okay, so let's just show this one together. 3x minus 2 equals 6. Go ahead and put a y above that in your notes, you guys. I'm going to line my ruler up with 6 on the y-axis and see where the graph intersects it. It's right there. Doesn't want to color for me. And then I'm going to turn my ruler and see what my x coordinate is right there when y equals 6. And it looks like it is 2 2/3. It's right there now. So for number 3, x would equal 2 2/3 and y equals 6. And that's my ordered pair. Owen? Yeah, it is okay because they didn't give you, but you know, actually, I'm sorry, let me no, it's better if you use fractions, because if you look at the divisions, right, they're divided into thirds. This is just like a bar model, little teeny tiny bar model on your graph paper, isn't it? So it's 1/3, 2/3, and then 3/3, like when that was that whole number. So you should use fractions on that. All right, let's skip B for a second, okay? And let's go to D. Says use the graph to solve for x. 2x minus 1 equals 9. Looks like my graph is funky on this one. It probably was hard to scan. All right, so here's my function. Y equals 2x minus 1. In number 1, it says 2x minus 1 equals 9. So what does y equal for 3a number 1? What is y for that one? I'm looking right here. Kylie R? Yep, y is 9. You can go ahead and put a y above that. So I'm going to use my ruler. Let's line it up with the 9. And it intersects the graph right there. So let's flip it and see where that intersects with the x-axis, which is right there at the 5. So when y equals 9, x equals 5, and this is how we write our ordered pair. Remember, x comes first, 5, 9. So I still see some like looks of confusion. How are we feeling about this? Okay. All right. Let's do number 2 there. It says 2x minus 1 equals 4. You guys have this in your notes, right? Or no, you don't. So go ahead and copy what you see up there. Copy the problems into 3D. This was number 1. This was number 2. 3B. No, this is 3A. I'm sorry. 3A. All right. If 2x minus 1 equals 4, what is y? When we look at this problem. Piper? Y equals 4 this time. We want to find out what x equals. So let's put our ruler on the y-axis at 4 and see where the line intersects. And it's right. Oh, I see what it's doing. It only wants me to draw lines when I have the ruler out. That's why it won't let me do a dot. Okay, there's where it intersects. The y-axis at 4. So let's go down here and see where it intersects the x-axis when y equals 4. And it looks like it's right here. So what does x equal when y equals 4? Uzziah?
X equals 2.5.
Yeah, x equals 2.5. So if we write that as an ordered pair, it looks like this. 2.5, comma 4. That goes in your 3D spot. So let's all make sure we're catching up on notes. Why don't you guys take a second, make sure you caught up on writing those problems down and writing the solutions into your notes, please. Shippy?
We also write it as 2.5.
Yes, you can also write it as 2.5. Declan?
Is the bottom one here?
It is 3, no, it's still 3A. It's the top one is number 1 and the bottom one is number 2.
Okay.
Once you finish catching up on notes, you guys can take a look at 3B and 3D, and we'll talk about those in a second. I am going to ask you guys to be writing ordered pairs on that final test. So make sure that you're practicing perfect and writing those in your notes. Do one more day of Okay, so let's talk about 2B.